Hello everyone. Welcome to my session. I know it's a bit before your lunchtime, so I'll try to make this worth it. So let's move on. Uh, a big thanks to our sponsors, because without them this event would not have taken place. So I would urge you to pass by their booths if you haven't already. Talk with them, network with them, because I'm sure there are opportunities, as far as I have seen, from all the notifications coming in and out every day and since yesterday. So take the opportunity, go visit their virtual booths, discuss about business opportunities or career opportunities. And while at it, get some giveaways anyway. They're giving some very cool prizes there. Okay, so a few bits about me. I've been working with SQL pretty much all my, let's say, professional life. And I like to consider myself a SQL Server performance tweaking geek. And the thing is, I love working with data and also Azure. So it's a good mix of both worlds. You can find my blog at sqltattoo.com and my handle at sqltattoo at Twitter. I invite you all to join me in this blog that I have there and subscribe so you get my feeds. I try to put as many as interesting things I can find, and I can also, based on my real life and work experience, to share information that will also either make you also feel more, let's say, share experiences in order to tackle also problems that might be also facing at your work. Microsoft Certified Trainer. I'm also welcome you and invite you to join us if you are in Greece, Cyprus, or Malta region, to join us in Cloud Experts LinkedIn group, a group for Microsoft Certified professionals for this area, where we let's say cooperate in terms of we work together and discuss about certification issues or career opportunities that might come up, and also do a lot of seminars and things like that. So this is something that has started this semester, and I'm very excited because a group of people has come together for this, and we're working very close with the Microsoft local office. So what are we going to see today? We're going to see, and we're going to discuss throughout this module, throughout this session, how what is, let's say, the proper design, the proper data services, whatever we need in order to make a good and solid design for our data services architecture on the cloud of Azure. So we're going to start with understanding the different data store models that we have on Azure offerings. Then we're going to see directly the specifics of Azure data services that we have in terms of products and their features. And then as a demo at the end, just because we need to get some hands dirty, we're going to configure Azure SQL Database with high availability, with some PowerShell, and also checking Portal and some tools there to see how this corresponds to the deployment. So as it says there, every solution has some core requirements like availability, durability, consistency, meaning you care where your data services are stored because you need them to be highly available at all times. And depending your scenarios, you may need high availability, right? So you need your data to be durable so you can sleep at night, and you also need consistency, most likely, right? Unless you have like a social media application, so even if you lose one like, maybe it's not a problem. But if you lose one transaction, for example, in a payment, this could be a problem. So other factors also that affect your data architecture is latency, for sure, because of maybe your application could be a bit chatty. Not that you write bad applications, but it could be chatty, and chatty applications with high latency is a nightmare, right? And of course, as everything, it has a cost. So cost is a crucial data factor for everything that we deploy in Azure and in general. But in Azure, it's something that you can control, and you have good control over it. So right. So let's understand the data store models. Modern business systems manage different types of data, as we say, heterogeneous data, right? So what we hear most of the times when we're talking with software solution architects and other parties like that, where they talk about something called a polyglot persistence data store. What this means is that with the introduction of microservices, this has also expanded quite a lot. So it means that each service, that each application that you may have in your solution in general could have its own data store. So in order to tackle this, Azure gives you a lot of offerings in terms of data stores. And we have the traditional relational database management systems, where we have, SQL Server, right? Azure SQL Databases and MySQL, PaaS offerings. Then we have key value stores like tables. Then we have document databases like Cosmos DB and MongoDB, graph databases like Cosmos DB with Gremlin API. And we have also data analytics. So data analytics is for sure Azure Synapse, right? So the invent of, let's say, the new SQL data warehouse on Azure. And then we have column family databases like Cassandra API and search engine databases. So we have Azure Search, or we have Redis. And we also have time series, because maybe you want to have some specifics like logging and things like that. So you have specific type of databases, so different data source for this kind of data to be persistent. And then you have object storage. Object storage is something that is quite versatile on Azure, and it's very important to understand what it offers. And one of the things that offers on the object storage, on the Azure storage, then we have shared files. So I would like to do a deep dive on some of them, because I find them more intriguing and more, let's say, popular. So they need more insight. So let's start with relational database management systems. So we have some environments here, so type of workloads that might be used more with relational database management systems, with RDBMS, traditional RDBMS data stores. So we have inventory management and order management and accounting applications. These are traditional applications that have been using RDBMS for many decades. So records are frequently created and updated. We have multiple operations that have to be completed in a single transaction, so the consistency is strong, and there are relationships that are enforced using database constraints. So all these are pointing to you using the RDBMS, right? And Azure services these kind of requirements with Azure SQL Database offerings, Azure Database for MySQL, PostgreSQL, and MariaDB. So we have the Azure SQL Database family, which are PaaS offering. All these are PaaS offerings, right? And then we have the community open source type of databases like MySQL, Postgres, and MariaDB. Then we go to key value stores, because key value stores are also a way to persist information for data that is accessed using a single key, like a dictionary type, right? So it doesn't need no joins, it doesn't have locks or unions. So it's like it doesn't have any kind of aggregation, let's say, mechanism. So there are applications that can be used that can leverage this kind of data source, like session management and data caching applications and implementations, as well as we see, the user preferences and profile management. So Azure services that can serve this kind of data store are Azure Cosmos DB Table API and SQL API. So as we will see later on, Azure Cosmos DB it has a lot of APIs that you can use, and so with the same engine, you can talk to different kind of, let's say, to understand different kind of APIs. So it's something that has like a polymorphic, let's say, engine that sits on Azure, and it's quite versatile and can be used for many things. Then we have Azure Cache for Redis. So it's like a PaaS offering for Redis. It's a native, very good implementation of Redis that has been done side by side with the Redis team on Azure. And also the Azure Table Storage, because as we said, so Azure Storage Account has one of the features that it has, it is that it can natively support table storage data stores. Document databases are something that you can use for product catalogs and content management or inventory management, right? Services can be used as Azure Cosmos DB with SQL API, and document database stores a collection of documents. So where its document consists of name fields and data. Documents don't need to have, let's say, specifics, and they don't need to have the same structure. So they're not so, there's not fixed in their schema, right? They can do insert and update operations are common. There are no objects, let's say, relational impedance mismatch between them, and the documents can better match object type of structures and not so much of relational with the logic that we know of relational databases. Coming to object storage, it's a storage that is generic in nature, and you can put almost anything in there. So you can save almost anything in there. So you can put images, videos, office documents, PDFs, as it says, log files, and even database backups or whatever might you think about it, right? So the services that are suited for this kind of things is Azure Blob Storage, that we're going to dive deeper a bit later, and also Azure Data Lake Storage Generation 2. So object storage is optimized for storing and retrieving large binary objects, as we said, right? And it's identified by a key. The content is typically an asset, like an image file or a delimiter file, Parquet files, or even video files, right? And the content must be durable. By durable meaning an external application. So it has to be there for the application to take benefit of it. So by using Azure Blob Storage, you gain rich and durable storage for your files with very, very low cost. We're going to have a look on this later and discuss a bit about Azure Data Lake Storage version 2, generation 2, which is very interesting also. Now the Azure Blob Storage. The Azure Blob Storage is, as it says there, it's resilient, right? It's a managed storage service that is highly available and secure, durable, scalable, and redundant. So it's something that Microsoft has for you as an offering in a very low price, and you just take it just takes care of it for you. So it's always there for you. The blobs are basically files, right? And it's the most flexible storage type on Azure. So you can store from files to pretty much anything, as we said. And blob storage, they don't have any structure. They don't have any hierarchical logic, unless you, at the creation time or even afterwards, you enable the Azure Data Lake Storage Generation 2, which then transforms the containers to the logic of blobs. We will have a look afterwards. And the thing is that by enabling the Azure Data Lake Storage, you get this hierarchical support and you get a very good solution for loading your data in an ETL process. So you get a very fast and blazing performance for your ETL process with large files, right? It's a very important concept to understand, the blob storage, because of its nature and its and all of these offerings it can give you. You probably can use it for many things, right? It's like a Swiss knife. It can be used for almost anything in terms of storing information. So as we see, and we're starting to see and get a feel of the Azure Data Services, Azure has a wide spectrum of services, and it suits almost any business need, right? And they're getting services out every now and then. So most like every once or twice a week, we have new things coming out, either in preview or in general availability. So there are things that are coming out most of the times, and they're either in infrastructure as a service or platform as a service. But our job is to understand which is better and what fits in our workload. So infrastructure as a service is like you deploy your compute and then you have to manage the resources and maintain it. This could be a nightmare depending the how wide is your solution and how many, let's say, staff is in your team. So it is something that can give you a very granular control over it, but it also could be a very costly thing, because apart from the platform, you also have to pay the compute, right? While on the other side, platform as a service is something that Microsoft takes care of it. So Microsoft takes the management out of it, like patching and securing and all this kind of stuff goes away from you, and you just focus on your application or your solution, right? So in the infrastructure as a service logic, we have what everybody knows is the Azure SQL VM, right? It's like having your on-prem VM, either physical or VM, it doesn't matter, but it's like the same thing. It gives you the same almost 100% seamless logic of taking your load from your on-prem, putting it on Azure VM. It just works, right? So it has a very granular control over your operating system, and the only thing you don't see is just the server, let's say, per se, but from the operating system and up, it's yours, right? And of course, it's easy to vision either through Marketplace or bringing your own custom VHD on it. The good thing is that the past maybe year or so, things are coming out for even to assist in the management of Azure SQL VMs. So there are extensions that are scanning your subscription if you want to enable this one, and it finds your SQL VMs, and it enables that extension, this EAS VM extension for Azure SQL, and then it gives you the opportunity to manage it like it was like a PaaS offering. So it gives you like time windows for patch management, so you can automate your patch management based on your time window that you have open, maybe Fridays or Sundays. It can also give you backup to Azure backup, so you don't have to take your backups in either shared files or somewhere on another server, or putting in the storage or things like that. You can leverage Azure SQL VM for Azure backup, which is a very good solution, and also it can be geo-redundant, so you don't have to worry about the region that you are going down, because your database is also your data file, your backups are also stored somewhere else in another region. It also runs on Windows and Linux, so it's a matter of preference, or a matter of what your solution uses. But the cost can be significant, right? The good thing is that with Azure Hybrid Benefit, you can leverage your on-prem licensing that you have with software assurance, and you can just bring it on Azure, and you can benefit from a huge percent of 80% discount. So this is something that you should definitely think of when you do infrastructure as a service on SQL VMs. Now moving on to PaaS offerings, the Azure SQL family moving to PaaS offerings. So we saw EAS and infrastructure as a service, and then we go to PaaS offerings. On the PaaS offerings, we have Azure SQL Database, and Azure SQL Database can start from very small, and it can grow to a hyperscale. So what is called a hyperscale, it's just huge infrastructure behind that works for you, and but let's don't get ahead of ourselves anyway. So Azure SQL Database, right? It's an offering that can give you almost 99, or not almost, it gives you 99.95% of availability. So if you're using business critical with zone redundancy. So there's no server management, it's fully managed. It's ready to work with just minimal configuration from your side. So maybe security, it would be good to have some security measures anyway when you do something on public. So you just deploy it and you just restore your database and it works, right? It's cloud ready, meaning there are less compatibility with on-premises. So it doesn't have the logic of the infrastructure as a service, right? Of the VM. So Azure SQL Database is evergreen, as they say. So it's always in the latest version of SQL Server. This could be something that could break your compatibility level on your application, or your in general could be something deprecated and could just break your application. So it's something that you have to test before you move there. There are offerings and pricing models that are very flexible and has to do with two types of logic. It's DDUs and vCores. vCores are let's say moderately newer than DDUs for sure, because DDUs was the first logic of pricing. We're going to have a look afterwards in more detail what are DDUs and vCores. The thing is that Azure SQL Database as a PaaS offering gives you automatic scaling, while with the infrastructure as a service you have to do it by yourself. So this is something that you should take into consideration if you are having systems that have high loads and low loads, and you need something to go up and down based on the workload. On this side also, the SQL Elastic pools, so you can have a pool of SQL databases that can grow and shrink based on the workloads. This is something that it's a PaaS offering, as I said, right? And it means that you have to think of what is more important to you, right? There are offerings for Azure single SQL databases, and also for in terms of Azure SQL Database and Elastic Pool. So there are 2 or 3, even serverless. So it depends exactly what you need in order to choose out of these PaaS offerings. Another PaaS offering is a managed instance. So managed instance is, for me, it's a great approach from Microsoft in order to try to move on to move the customers from traditional VMs to PaaS offerings, because it gives you almost 100% compatibility with your VM infrastructure. So it provides also 2 levels of isolation, the compute level and the network level. So it gives you a high availability, a high level of isolation and security for your data, because what it does, it's just deployed in a virtual network as machines for you, right? So you have compute isolation level that ensures your instances and databases are not shared between customers, and that machines do not cross borders with other customers. So there are native virtual network support, and you get also benefits of the public cloud while remaining isolated from the public internet. So it's a very good offering, and I would urge you to have a look on it if you are planning to move on to infrastructure as a service. Take a good look at managed instance before. Cosmos DB. So Azure Cosmos DB is the NoSQL and the NoSQL flavor of Azure SQL Database on Azure. It's a native pure breed of cloud offering. So it was created on Azure for Azure. It's fully managed, and it is what we call schema agnostic. So it automatically indexes all the data without requiring you to deal with schema and index management. And it's also multimodal, so it has natively support for documents, for key values, for graph, as we said, and also column, all these kind of APIs that can interact with different sets of data. And it features geo-replication, so you can have your data spread all over the globe very fast and very easy with just clicks in reality from Azure portal if you want. And you can also have elastic scaling of throughput and storage worldwide. So the good thing, Azure Cosmos DB is blazing fast because it sits on top of SSDs. So it's very fast in terms of less than, it's like millisecond type of response, right? Another cool thing with Azure Cosmos DB is that maybe 2 weeks ago or maybe 3 weeks ago, but I think it's a couple of weeks ago, Azure Synapse Link got integrated with Cosmos DB. So now what you have with this is that you can have your real-time data being transferred to Azure DB for near real-time insights, right? Without impacting your operational workloads. I hope you have seen the Andonis Hadjipavlis session on analytics and Synapse. it's a great tool. I do believe that Synapse is a way to do big, let's say, big analytics on things like data warehousing and things like that. It's a tool that very, let's say, expanding all the way. The good thing about the data link is that you don't have ETL analytics, so you don't do ETL for this. Now, there are some availability and scalability trade-offs. So there is a consistency thing about the Cosmos DB, starting from the left to the right. The stronger you have the consistency, the less, let's say, availability you have, or better scalability in reads. So both of the two worlds could be maybe session, but you have to check your boundaries and see what is better for you. In past offerings, there are open source community, of course, as we said, offerings. So we have Azure Database for MySQL Server and Azure Database PostgreSQL. Both of them offer 99.99% SLA with single zone or zone redundant high availability. They are built with the latest community editions, and it can give you access to existing tools like, for example, MySQL Workbench when we talk about MySQL, or programming languages and drivers that you use already with, including PHP or Java, Node.js, and even .NET, of course. So with Postgres, on the other side, you have full compatibility with all the community PostgreSQL versions, and you can use your frameworks like Ruby on Rails or Python with Django. And there is also an extension for Azure Data Studio and PostgreSQL over in GitHub if you want to have a look on this one. Postgres, on the logic, is that Postgres is for, let's say, complex structures, and it can also go Berserk and hyperscale itself. So it's quite good if you have to do sharding and things like that. So with the logic with a hyperscale out of the box with Citrus extension. So for sure, there are a lot of offerings, even community offerings as a service for Microsoft. So I'm urging you also to have a look on them too, if you are already using them. Now let's do a bit of a deep dive on Azure SQL Database family. So there are different data service tiers. So there is a general purpose and business critical and the hyperscale. But hyperscale, there is no support for SQL management instance at that moment. So general purpose is designed for budget-oriented workloads. So it's not so much maybe for production workloads, or maybe for workloads that it doesn't matter even if you have, let's say, an outage of 1 hour, 2 hours. So it's not something critical. Business critical, on the other side, is designed for low latency workloads with high resiliency and to failures and fast failovers. So Azure SQL has this kind of offerings in order for you to choose what is better for you in terms of also cost, but also business-wise, right? Here, as you see at the bottom, suppose you see, there are DTUs, and it explains what are the DTUs versus the vCore. So DTUs are a mix of compute and storage and I/O, right? It's simple and it's pre-configured. You may benefit because you don't have to think about it too much. You just, let's say, okay, I need this kind of DTUs, and just give it to me, and just provisions to you also the storage and I/O that it needs to support it. On the other side, you have the vCores that has a clear separation between the compute and the storage, and they can scale independently from each other. While DTUs, you just slide, let's say, the DTU and just scales everything. So I/O, compute and storage and everything. So depends what you prefer. vCores are mostly aimed for the ones who are taking workloads from on-prem, and they know how much storage and I/O and all these things they need for their application, and they just need to port it with the same logic on Azure. So you can use this. Now, general purpose has this kind of design. So it has a storage account and it has compute nodes. So the storage account is blob files where your databases are stored there. The active compute node, SQL Server, so SQL Server exe, right? It runs somewhere and it just traverses all your data files and does your quiz on your on the Azure Storage account, right? And in case something fails, one of your nodes fail, another of the stateless, let's say, because these nodes are stateless, only your data has state, it takes its place and just you have some downtime there and it just works, right? On the other side, the business critical works like this. So it's always on availability group, right? And they have primary replicas and secondary replicas, so everything is in sync, and you have replicas, and you can do read-only things on your read-only replicas. But your storage is very fast because there are local SSD storage on the servers. So it's a matter of what kind of, let's say, workloads demands you have in order to pick the correct one. Now, for single databases, because we also mentioned SQL databases, single databases can give you serverless tier. It can be very beneficial in terms of auto scaling. So when you need it, it just scales. But when you don't need it, it just pauses. It goes in an auto pausing state that you can save money for it, right? Now, the business critical in terms of DTUs is called premium, and the general purpose is called standard service tier in DTUs. This is the jargon, so in case you come up to it, so you understand what we're talking about. Now, security. Security in Azure SQL database, we have TLS, so we have encryption in transit. Whatever is transferred by default is transferred securely over the SQL database family. Even if you use site-to-site or use express route or whatever, all these transfers are done securely over TLS, depending your version of 1.1 or 1.2. Then we have encryption at rest. So encryption at rest is done through transparent data encryption, right? Transparent data encryption encrypts your entire database from unauthorized access to offline access and backups and things like that. You can bring your own key by putting it to Azure Key Vault if you don't want to use the Microsoft one, and you just rotate your own keys afterwards. At the end, not the end, but next we have the encryption in use. So what we call encryption in use, so always encrypted. Because maybe even while you use your data in your application, you want some parts of it to be always encrypted, meaning that if the user that uses the app doesn't have access to the key, he cannot see parts of the data. All right. And then dynamic data masking, if you want to obfuscate or mask parts of your data, like social security numbers or some other maybe I don't know, some other sensitive data that you don't want to share with any other that has access to the application. One important thing about always encrypted is that even the things that are encrypted cannot be even accessed by administrators. So even your database administrator don't have access there. And another thing is data discovery and classification, which is very important also, and it's something that it makes your database be able to understand what are the sensitive data, find them, label them, and then also monitor them for someone trying to, let's say, access the sensitive data and alert you in order to have a look out for this. Let's go to the demo. Let's switch here. Okay. So what we have here is our PowerShell. We have Visual Studio Code. We have some resource groups, so we are doing some assignments here. From time, I think we are just like 10 minutes or something. Yeah, so, okay. So we have resource group. We assign the variables here. So let's run this one. Okay, yeah, we have to run this also. And then run this. Okay. We are setting the context and we are assigning the variables here. Okay, this is my IP, so we can put it on the firewall, and we are getting the information we need to connect afterwards. Now, what we're going to do here is we're going to create a server with a system-wide unique server name, because it has to be system-wide unique. And what we use is new this commandlet, Azure SQL Server. We pass all the variables that we used that we created previously: server name, location, where it's going to be located in Azure region. The credentials we created afterwards, we pass them as SQL administration credentials, and then we create the host. Right. So let's have a look on the portal for this IT Pro Dev 2020. So here, as you see, we have nothing in this resource group, IT Pro Dev 2020. So let's go back and try to create something out of it. Okay, so let's create this server. Now, what it does in the back, it goes and creates this primary logical server that we need in order to host our Azure SQL database. So while this is running, let's have a look on the second one. So what is the thing that we do afterwards? So we're going to create a firewall rule for connecting to our primary logical server, because by default we cannot connect. So we need to create a rule in order for us to be able to connect to our server, right? So let's create also that rule. Now we cannot create because it's still running. So let's move on explaining the rest of the query, and then we run it run it afterwards. Now, okay, so this was created. Okay, so let's create also the rule now. This should not take long. Yes. So let's go back and see what has been created for us. Nothing till now, so we have to wait a bit. This is eventual consistency, so sometimes it might take some time to be seen here. Okay, so afterwards, after we create the server, we create our firewall rule, then we have to create the database. So let's create the database. What we do here is we give it a server name, the one we created above, a database name, just the name that we use. What is the edition? So it's general purpose because it's for us testing here. So 2V core, so we don't waste my subscription and get depleted. Computer generation 5, which is the one that is, let's say, proposed currently from Microsoft, and give it a sample name for workload. Okay, let's fire this up also. While we wait, so we should have our server here. Yeah, so you see we have our server here created, primary and SQL Server, and location is West Europe. So if we go in here, okay, so sorry, you were not seeing. So yeah, now you see. Okay, so I was telling you that this is the server that was created. So this is our primary logical server, and its location is in West Europe. Okay, so let's go in there and see what's going on. So we know that it's available. We see the status here. We also see the firewall settings, and we see that there are no failover groups created yet, right? This is what we're going to do now. Now, the database is something that is created as we speak in the back here in our VS Code that we fired before. So let's have a look on DTU and quotas. So as you see, what we have is that we have 2 vcores, what we created earlier. Okay, so let's skip back to our code to create the secondary logical server, while we explain also the database now. And let's also run this also to create the server. To create also the firewall rule for the secondary. So this is the same thing. We just create a secondary server to a different location, right? So the first location was West Europe here, West Europe, and the other location is North Europe. Okay, so let's go back and run to create the secondary server and its firewall rule. Okay, so let's go back while this runs to check the Azure portal. Okay, so what we have in the server here, we also have the SQL databases. So this is the database that was just created. So it's online, it's general purpose generation 5 with 2 cores as we expect it to be. Okay, so let's have a look. Let's see the firewalls before we move on. This is the firewall that we did. So this allowed my IP to connect now. Otherwise, I wouldn't be able to connect on the server and then to the SQL database. Connection policy, just a quick rundown. This is proxy and redirect. The default is proxy. Faster is redirect, so it needs a bit of tweaking on your NSGs to open more ports. If you don't care so much about performance for your test, then you can leave it as a default. And this is the TLS version. Okay, so you can use any of that fit your workload needs. Okay, so I see that this also finished in the back, but let's check the database. So let's go back to our resource group, do a refresh here. Now we should see also our database. Okay, so this is a SQL database, as you see. It's also located in West Europe, and as you will see here, let me zoom a bit. Yeah, so as you see here, this says that it's located on this server, right? Which is this one. So let's have a look closer to this one. So it's online, it's in West Europe, it's sitting on this server that we created, that we saw earlier, right? Has some information. What we care to see about is configuration. So we check the vCores as we saw. Yeah, so it's general purpose, and it has provisioned 2 cores, and this is 32 gigabytes of storage. And if we scroll all the way here, you will see costs, regarding costs, right? And you, from this side, from this view, you can also change it to zone redundant. So by with one click away, you can change to 99.95 SLA. In case you want to, this is provision in serverless, so you can choose what kind of service tier of computer you want. And if you're going to go to DTUs, then you can go from here and just change to DTU, let's say pricing. Now, geo-replication wise, yeah, we don't want to change anything here. So geo-replication wise, you'll see that we don't have something here, right? So the database is running in West Europe, which is a primary and doesn't have any failover policy, and this is a server database. So geo-replication is not configured, no secondaries. Okay, let's fix that. Let's go back to our code. And what we're going to do now, since this has finished, we're going to create a failover group. So we're going to create a failover group using the command, the PowerShell commandlet, AZ SQL Database Failover Group. We're going to pass a resource group name, the server name, which is our primary server, and then the DR server name. And we're also going to use a failover group name. So we're going to just give it a name, so a logical name. This grace period with data loss hours is 2 hours. This means what? You have a 2-hour window if you want to fix it before it before it failovers. So maybe you don't care if for 2 hours you're just trying to fix it and you don't want to automatically failover. So this gives you this amount of time. So let's create this failover group here. Okay, so while we wait for this, let's go back. Logically, we should be seeing here the 2 other databases. Yeah. So you see, this is the secondary server. There's no database yet, so we have the secondary server here. It's just one server. The only thing that we have done here is to add RIP with the firewall rule that we created earlier, right? But there are no databases here. Okay. So let's see. So this finished. It created the failover group with this name that we gave. It's in West Europe. Okay. So all these things are as we requested to be. Now what we're going to do is going to add the database to the failover group. Okay. So let's add that. So AZ SQL databases in this resource group, this server name and database name. So, and then we're piping this to add to the database failover group. So what we're doing is we're taking the primary database and from the primary server, and we're just adding to the failover group. Okay, let's run this. This shouldn't take long also. Let's hit a refresh here and see what's going on. Let me have a look here. Did I run this? Maybe I SQL database failover group. Yeah, I have run this. Logical server. Okay, yeah, seems fine. So let's see how it goes. Okay, so while this runs anyway, we can switch to our to portal. Okay. Okay, let's have a look at Geo application, a sneak peek to see what's going on. You see, so this one now is seeding to North Europe. So we have Azure SQL secondary server is kicking on as a secondary, right? And it's just seeding now. So this worked. So we create the failover group and we added the secondary on North Europe, and now we have geo replication between the two locations. So you see, we have failover with data loss grace period 2 hours, and it's fine. Now, how we can check which role has databases? Okay, we have AZ SQL Database failover group, and we just pass replication role, and we can get this information. So we know that the secondary is a secondary. So we are confirming that the secondary server is a secondary. Now, what we can do is that we can switch. We can do a failover, right? But before we do say, okay, so we see that it's now in it's in a standing. Yeah, sorry. So it's readable now. So we see that it has finished seeding and everything looks fine. So switching back to our VS Code, we see that our failover group. This is what probably you missed afterwards because I forgot to switch between the screens. So we have the secondary that is secondary, so it's correct. Now what we're going to do is going to fail over to secondary server. So we're going to use this commandlet switch AZ SQL Database failover group, okay? And we're going to switch to server dr server name, okay? So let's switch now and see what this does. Let's go switch back to the portal while this runs. And let's go and see what's going on here. So you will see at some point that this is changing. Let's go. Yeah, you see things are going there differently. Now primary is North Europe and West Europe is secondary, right? So things have shifted. Okay, great. It works as it should. So the only thing that remains to see is how we switch back. So how we switch back, we use the same, but we just revert the variables, right? And we should be able to see the switching back. Now what you see here is that we have primary and secondary server, right? And then we have the primary and the secondary databases. So one is in West Europe and the other is in North Europe. And this, I think we're almost out of time, but let me check. Yeah, we're out of time. So thank you very much for your time. I hope you enjoyed the session, and please don't forget to evaluate and give feedback for the session and overall event. So take care and see you in the next event. Bye.